Hello students, welcome to Akshar Academy YouTube channel. In this session, I am going to discuss vectors. In this, scalar or dot product. If you like this video, please subscribe to our channel. Please share your valuable comments in the comment section. Okay, let us go to the today's session. First one, scalar product or dot product. Let us discuss. Dot product of two vectors is defined as the product of their magnitudes and the cosine of the angle between them. These are the two vectors, one is p bar and other is q bar, making the angle theta, cosine of the angle between the two vectors. Product of their magnitudes and the cosine of the angle between the two vectors. The scalar product of the vectors p bar and q bar is defined as p bar dot q bar is equals to magnitudes modulus of p and modulus of q cos theta, or magnitude of p bar and magnitude of q bar cos theta. Product of their magnitudes and the cosine of the angle between the two vectors. So, p bar dot q bar is equals to magnitude of p bar and magnitude of q bar cos theta. Here theta is the angle between p bar and q bar is given by cos theta is equals to p bar dot q bar by modulus of p bar modulus of q bar. Theta is equals to cos inverse of p bar dot q bar by modulus of p bar and modulus of q bar. Now we'll discuss properties of scalar product. The dot product between the two vectors obeys commutative law. That is p bar dot q bar is equals to q bar dot p bar. Dot product obeys a distributive law, that is p bar dot q bar plus r bar, that is equals to p bar dot q bar plus p bar dot r bar. It is always a scalar which is positive if angle between the vector is acute nothing but less than 90 degrees, and negative if angle between them is obtuse, nothing but the angle between 90 less than theta, that is less than or equal to 180 degrees. If it is a scalar which is positive, if the angle between the vectors is acute, and negative if the angle between them is obtuse. Scalar product of two vectors will be maximum when cos theta is equals to 1. That is theta is equals to 90 degrees. That is vectors are parallel. When the two vectors are parallel, its scalar product of two vectors will be maximum. So that implies p bar dot q bar maximum, that is equals to pq, or p bar dot q bar is equals to p of q cos theta, that is equals to q of p cos theta. So the vectors are orthogonal, that is perpendicular when theta is equals to 90 degrees. So that is p bar dot q bar, that is equals to pq cos 90 degrees, that is equals to 0, because cos 90 is equals to 0. In case of orthogonal unit vectors I cap, j cap and k cap, I cap dot j cap, that is equals to j cap dot k cap, that is equals to k cap dot I cap is equals to 1. If p bar is equals to px I cap plus py j cap plus pz k cap, and q bar is equal to qx I cap plus qy j cap plus qz k cap. P bar dot q bar is equal to px qx plus py qy plus pz qz. Now I'll discuss examples. Scalar product of force and displacement is called work done by that force. So that is W is equals to F bar dot S bar. Dot product between force and velocity vector gives power. That is power is equals to F bar dot S bar by T. That is equals to F bar dot V bar. If a magnetic dipole of moment of M is in a magnetic field of induction B bar, the potential energy of the dipole is given by UB is equals to minus M bar dot B bar. Now I will discuss vector component. See here, P bar and Q bar are two vectors and angle theta. Component of Q bar along P bar, that is equals to Q cos theta, that is equals to P bar dot Q bar by P. So that is equals to P bar dot Q bar. The vector component of Q bar along P bar is Q cos theta P cap, that is equals to P bar dot Q bar by P into P cap, that is equals to P cap Q bar of P cap. Component of P bar along Q bar, that is equals to P cos theta, that is equals to P bar dot Q bar by Q, that is equals to P bar dot Q bar. The vector component of P bar along Q bar, that is P cos theta Q cap, that is equals to P bar dot Q bar by Q into Q cap, that is equals to P bar Q cap into Q cap, that is P bar dot Q cap into Q cap. So the component of P bar perpendicular to Q bar and in the same plane is C bar, that is equals to P bar minus of P bar dot Q bar of Q cap. The component of Q bar perpendicular to P bar and the same plane is, that is D bar is equals to Q bar minus Q bar dot P bar of P cap. Now I'll discuss MCQs. Dot product of vectors is a vector, scalar, tensor, none of these. Dot product of vector is a scalar. Next, if L1, M1, N1 and L2, M2, N2 are the direction cosines of two vectors and theta is the angle between them, then the value of cos theta is L1, L2 plus M1, M2 plus N1, N2, L1, M1 plus M1, N1 plus N1, L1, L2, M2 plus M2, N2 plus N2, L2, M1, L2 plus L2, L1, M2 plus N1, M2. The value of cos theta is L1, L2 plus M1, M2 plus N1, N2. First option is correct. A force F bar, that is 6I minus 8J newtons, acts on a particle and displaces it over 4 meters along the x-axis and then displaces it over 6 meters along the y-axis. Then the total work done during the two displacement is 72 joules, 24 joules, minus 24 joules, 0. Let us discuss. Here given F bar is equals to 6I minus 8J newtons. Yes, they given here 4I minus 6J meters. Work done W is equals to F bar dot S bar, that is 6I minus 8J dot 4I minus 6J. 6 4s 24, 8 6 are 48, 24 minus 48 minus 24 joules. So the total work done during the two displacement is minus 24 joules. Now I'll discuss vector product of two vectors. Multiplication of vector. There are two types of vector multiplication. One is scalar product, dot product, vector product or cross product. We have already learnt about the dot product of vectors in the previous lessons. Now I'll discuss Cross product or vector product of two vectors. Cross product or vector product, let us discuss. B bar is a vector and A bar is a vector. A bar and B bar are two vectors making an angle theta. So A bar cross B bar is equals to AB sin theta into n cap. So this is cross product. This is angle between the two vectors. Here theta is the angle between two vectors and this is the cross product. And it is the unit vector. N cap is the unit vector. A bar B bar cross A cross B. Here A cross B or B cross A. Here A bar and B bar are the two vectors making an angle theta, and this A bar, modulus of A bar, modulus of B bar, sin theta. Now I will discuss two vectors A bar and B bar making an angle theta. So its vector product is A bar cross B bar is equals to AB sin theta into n cap. When we are interested in finding the magnitude and direction of the resultant vector, we go for cross product. So magnitude of resultant vector is given by modulus of A bar cross B bar is equals to AB sin theta. Direction of resultant vector is given by A bar cross B bar is equals to AB sin theta into n cap. N cap is a unit vector. Now I will discuss modulus of P bar cross product of Q bar, that is P bar cross Q bar, that is equals to PQ sin theta, or P of Q sin theta, or P of component of Q bar perpendicular to P bar. So Q bar cross P bar is equals to QP sin theta, or Q of P sin theta, or Q of component of P bar and perpendicular to Q bar. Let us understand when these red lines are present. These now discuss. Significance of cross product. Q bar, P bar and Q bar are the two vectors making an angle theta. See the picture carefully. In triangle BAC, therefore sin theta is equals to AC by BC. Sin theta is equals to AC by BC. Opposite by hypotenuse. Sin theta is equals to AC by P. BC nothing but it is a vector P bar. So sin theta is equal to AC by P. Therefore AC is equals to P sin theta. So modulus of P bar cross Q bar, that equals to PQ sin theta, or modulus of Q bar cross P bar is equals to QP sin theta. Now A bar cross B bar is equals to AB sin theta into n cap. AB sin theta nothing but magnitude of resultant vector. N cap represents direction of resultant vector. So magnitude of resultant vector, that is modulus of A bar cross B bar, that is equals to AB sin theta. This is right hand screw rule. What does right hand screw rule mean? Let us discuss. A bar and B bar are two vectors making an angle theta. Now A bar cross B bar is equals to, see here, screw will go inside. This is the direction of the screw. See here, A bar cross B bar is equals to C bar. This is the screw rule. Rule of the right hand screw for defining the direction of vector product of two vectors. So resultant vectors have direction going into the plane of screen. A bar, B bar are two vectors making an angle theta. Now B bar cross A bar is equals to, screw will come outside. So resultant vectors having direction coming out of the plane of screen. Now I will discuss characteristics of cross product or vector product. The product is a vector, and if A bar and B bar are given, the vector product is A bar cross B bar is equals to AB sin theta into n cap. It is directed at right angles to the plane containing the two vectors, and its sense is given by the right hand thumb rule. Fourth one, if two vectors are parallel to each other, magnitude of vector product is 0. If it does not obey the commutative law of multiplication. The magnitude of self cross product of vector is 0. That is A bar cross A bar modulus of A bar cross A bar is equals to 0. Now seventh one is modulus of A cap cross A cap, that is equals to modulus of J bar cross J cap, that is equals to modulus of K cap cross product of K cap, that is equals to 0. I cap cross J cap, that is equals to K cap. J cap cross product of I cap, that is equals to minus K cap. Similarly, J cap cross product of K cap, that is equals to I cap. K cap cross product of J cap, that is equals to minus I cap. K cap cross product of I cap, that is equals to J cap. I cap cross product of K cap is equals to minus J cap. Now I will discuss MCQs. If two vectors are parallel to each other, then A bar cross B bar is equals to 0, A bar cross B bar is equals to 1, A bar cross B bar not equal to 0, A bar cross B bar is equals to infinity. If two vectors are parallel to each other, then A bar cross B bar is equals to 0. In vector product, I cap cross I cap is equals to minus K cap. I cap cross product of I cap is equal to 0. I cap cross product of I cap is equals to J cap. I cap cross product of I cap is equals to K cap. In vector product, I cap cross product of I cap is equals to 0. The cross product of J bar and I bar is 0, 1, minus K, K. The cross product of J bar cross I bar is equals to minus K bar. Now I will discuss expression of vector in determinant form. An expression for cross product of two vectors and expression in determinant form. Let two vectors A bar and B bar be given as A bar is equals to AXI cap, AYJ cap plus AZ K cap, and B bar is equals to BXI cap plus BYJ cap plus BZ K cap. The unit vectors I cap, J cap and K cap being mutually perpendicular. So, modulus of I cap cross product of J cap, that is equals to modulus of J cap cross product of K cap, that is equals to modulus of K cap cross product of I cap, that is equals to 1. Since sin 90 is equals to 1. Therefore, I cap cross product of j cap that is equals to k cap, a unit vector perpendicular to both I cap and j cap. J cap cross product of k cap is equals to I cap, a unit vector perpendicular to both j cap and k cap. K cap cross product of I cap that is equals to j cap, a unit vector perpendicular to both k cap and I cap. So since vector product is not commutative, so j cap cross product of k cap is equals to I cap. K cap cross product of j cap is equals to minus I cap, and I cap cross product of k cap is equals to minus j cap. K cap cross product of I cap is equals to j cap. Since vector product of a vector with itself is 0, so cross product of I cap and I cap is equals to j cap cross product of j cap, that is equals to k cap cross product of k cap, that is equals to 0. Okay. Now a bar cross b bar is equals to ax bx of I cap cross product of I cap plus ax by of a cap cross product of j cap plus ax bz of I cap cross product of k cap plus ay bx of j cap cross product of I cap plus ay by of j cap cross product of j cap plus ay bz of j cap cross product of k cap plus az bx of k cap cross product of I cap plus az by of k cap cross product of j cap plus az bz of k cap cross product of k cap. So that is equals to ax bx of 0 plus ax by of k cap plus ax bz of minus j cap plus ay bx of minus k cap plus ay by of 0 plus ay bz of I cap plus az bx of j cap plus az by of minus I cap plus az bz of 0. Here we are substituting all the values of I cap cross I cap cross j cap, I cap cross k cap, and j cap cross I cap, and j cap cross j cap, and j cap cross k cap, k cap cross I cap, k cap cross j cap, and k cap cross k cap. All the values are here substituting. Now a bar cross product of b bar is equals to ay bz minus az by into I cap plus az bx minus ax bz of j cap plus ax by minus ay bx of k cap. Alternate method. Therefore, a bar cross b bar is equals to ay bz minus az by I cap plus az bx minus ax bz j cap plus ax by minus ay bx k cap. So, using determinant method, a bar cross b bar is equals to modulus of I j k and its components ax, ay, az, bx, by, bz. Now discuss MCQs. First one, find a bar cross b bar where a bar is equals to 2 I bar minus 5 j bar plus 3 k bar and b bar is equals to 3 I bar plus 4 j bar minus 9 k bar. Here options are given. Now let us discuss with the solution. A bar cross b bar is equals to I cap, j cap, k cap, and its components are 2, minus 5, 3, 3, 4, minus 9. So therefore, a bar cross b bar is equals to I cap of here 9 5s are 45 minus 12 and minus j cap of here 18 minus 18 minus 9, minus 9 into 2, 9 2s are 18, 3 3s are 9 minus 9 plus k cap of here 4 2s are 8 minus 5 into 3 minus 15 minus minus plus 15. So therefore a bar cross b bar is equals to 33 I cap plus 27 j cap plus 23 k cap. Here 45 minus 12 33 minus 18 minus 9 minus 27 minus into minus plus, so plus 27 j cap. Here 15 plus 8 23 k bar. Okay. Next, a force F bar is equals to 4 I bar plus 2 j bar minus k bar newtons acts on a body at a distance of q bar is equals to I minus I bar minus 3 j bar plus k bar. From the origin of an inertial reference frame, find the torque acting on the body. These are the options are given here and we have to calculate the torque acting on the body. Let us discuss with the solution. The torque acting on the body is given by tau is equals to R bar cross F bar. Therefore, tau bar is equals to I bar, J bar, K bar and its components are force and distance, that is minus 1, minus 3 plus 1 and 4, 2, minus 1. Therefore, tau bar is equals to I bar of here 3 1 ja 3 minus 3 minus 3 minus 1 minus minus plus 3 minus 2 minus j bar of here minus 1 into minus 1 minus minus plus 1 1 ja 1 minus 4 1 ja 4 plus k bar of 2 ones plus 2 into minus 1 minus 2 4 minus 3 minus 12 minus of minus plus, so minus 2 plus 12. Therefore, tau bar is equals to I bar of 3 minus 2 1. Here 1 minus 4 minus 3 minus minus plus 3 j bar. Here minus 2 plus 12, that is 10, 10 k bar. So tau bar is equals to I cap I bar plus 3 j bar plus 10 k bar Newton meter. This is the torque acting on the body. Okay. Thanks for watching this video.